All right, welcome back. We're going to look at this last graph of a polar equation. We have r equals 1 plus cosine theta. Be prepared, it's going to be a weird one. So first thing I'm going to do is look at the main angles for cosine, the peak, the valley, and all that, the high and the low. So when theta equals 0, we know cosine is 1. Pi over 2, we're down to 0. Pi, we're down to -1. 3 pi over 2, we're back up to 0. And 2 pi, we're back to 1. So remember, this is what your cosine looks like, okay? So if I have r equals 1 plus cosine theta, I'm just going to add 1 to all of these coordinates. So let's see if that's enough information to graph this. So when, just highlighting the columns, so when theta equals 0, we have r equals 2. So we have the point 2, 0, followed by 1, pi over 2, followed by 0, pi, which we know was the origin. Then we have 1, 3 pi over 2, and then we have 2, 2 pi. And pretty easy to see that from there, if I go beyond one period, it's just going to keep tracing over itself. So we know that one full period of this graph is going to go from 0 to 2 pi. Okay, so 2, 0 would be right here. 1, pi over 2 would be right here. 0, pi would be here. 1, 3 pi over 2 would be right here. And 2, pi, we're back here. So think about how the cosine changes as we go. So as theta increases, and remember, we're always looking at things going this way. As theta increases, we know that cosine is going to decrease from 2 to 1 here. And then it's going to shrink to go to 0. Now, at this point, it's kind of weird. It goes down to 0, and then it goes back up again, right? We don't have any other intercepts in there. So we're going to basically do the reverse of what we just did. And then back there. This is called a cardioid. And it looks like a little heart, doesn't it? So it loves math, apparently. So again, notice that it's centered around the x-axis, and that makes sense because of the cosine. But if you plotted more points, this is where you would end up. So there's the graph of our cardioid, and that basically wraps up all of the polar equations that we're going to graph. So hopefully you found this helpful.